So what will we talk about today? I thought about the following structure. So I start with some words about me, so you know who's talking. Then we go a bit about the history of BlueCast, like what inspired me, what is the vision. But I think it's also important to see, okay, there are people behind the framework, so what basically influenced them in their work. So maybe that also gives a better imagination of why the library looks like it is nowadays. Then we will do a business case walkthrough. So will be nothing directly from SumUp because I'm here also like privately. So everything I say represents me, not the company, just like as an official disclaimer here. But I thought it might be a nice to see how like a real world case might look like, what are the dynamics with different people, which profiles might appear. And then I talk a bit about Kaggle because there's lots of dynamics actually on Kaggle. If you don't know Kaggle, it's like a data science, machine learning competition platform. And AutoML has gained lots of attraction in the last months, also because of a certain event. Now we'll talk briefly about, so when you look at Kaggle leaderboards, what do you see and what don't you see maybe? And then a brief summary at the end. So about me. So I'm working at SumUp. If you don't know SumUp, it's a global card brand or card reader brand. So we are producing card readers and basically sell them, offer them in more than 30 countries in the world. So that small merchants can basically just do what they love and run their small business without having much hustle. In the past years, I worked as an analyst and data scientist, kind of like in hybrid positions or solely. And my first touch point actually with AutoML was like 4 to 5 years ago. The first AutoML solution I saw was actually called Data Robot. Did anyone hear about Data Robot in the room? Okay, some know, cool. So for the ones who don't know, and now it disappeared, hello? Maybe I can just refresh. Okay, I will click around, but maybe if I could have helped them with the presentation would be nice in the meantime. So if you don't know Data Robot, basically what it offers is it's basically a corporate platform, and you can just upload your CSV file or enter a SQL query or provide a data set in some form. And then, thanks a lot. And then Data Robot will essentially go through like a bunch of blueprints, like pre-processing plus machine learning, and then create a leaderboard, also has some ensembles, and basically tell you, okay, that's the best model. And then with like one click, you would also even put it into production and then basically serve it and you have monitoring. So it's kind of an end-to-end solution. And back then, when we actually talked about it in a company, and we also talked about should we use it, why should we use it, the general question was, are data scientists even needed anymore? We have like such a fully fledged solution. Do we really need them? I will answer this question later. Then when I was a junior analyst, I was super impressed and excited actually because I thought, oh my goodness, Data Robot looks so good because the UI looks also really nice actually. And then I started just building something myself for personal development. It was a bad package, honestly. That's why you never heard about it probably. So don't search for it. Just take the fact that I took lots of learnings from actually building that private project. And then at some point I was a bit like saturated with building something about AutoML. But sometime later I actually had a mentee myself. And then part of an exercise was that mentee actually wanted to learn machine learning. And then I gave him homework and said, okay, come. Now let's build some pre-processing in Python so you get used to it. And then together we build some machine learning. And the mentee actually struggled to do so. And then I said, okay, I show how quick this can be done. And then basically I coded it quickly and showed him. And actually then my hunger was back on fire and I really wanted to continue on this project. And that's where BlueCast was born. It applies lots of learnings from the other package. It does less, but it does it better. It's actually easy to start with, so I hope you will see this also then in the notebooks. There's lots of customization available, so it's easy to start with, but you can go very deep in what you want to achieve. It has lightweight dependencies, good performance, and also much better foundation. There's like almost 100% test coverage, there's documentation, and the library itself is quite maintainable. So, a business case walkthrough. So I thought about there are many topics that are nice if you think about doing some machine learning in a business case, but I think what everyone can talk about, or everyone thinks can talk about, is actually churn. So let's assume we are in a business, and let's assume it's a subscription-based business because that makes churn a lot easier. And our stakeholder comes to us and says, oh, we have too much churn. I looked at our Power BI dashboard and I'm seeing bad numbers. So looking ahead, we will have a very hard time. We need to do something about churn. And that stakeholder is actually, in our case, super smart. So he knows from previous roles he has had in other companies that we actually need data. So he went already there to different parts of the business and collected some data. In reality, this is a Kaggle dataset, by the way. So if I share then the materials, there will also be a link so you can actually download the data yourself or do it on Kaggle directly, however you want. And now the question is, okay, we have this data, but who will actually work with the data? And in real businesses, there are different personas. So we have the stakeholder, and usually with stakeholders, some have machine learning experience, but by far not all of them. But sometimes they had some statistics at university or have some coding experience in Python or R. So usually they sometimes even attempt to build their own models or draw their own conclusions by modeling something with the data they found in the business. So here, BlueCast could help making actually a benchmark to compare like the own solution against what BlueCast would basically offer. But we also have the analyst profile. And also here, these are, I framed them quite as stereotypes because behind such a persona can be lots of variance in how people fill these positions. Sometimes you have a data scientist who now works as an analyst. But you often face an analyst who has no machine learning experience. They're just pretty damn good in writing SQL and making beautiful dashboards. But now they have to actually deal with the churn problem. But some of these analysts also want to become a data scientist. So when then someone comes with churn, they think like, yes, that's my chance to get into data science because I can do some machine learning modeling. So for such a persona, actually, BlueCast could help making them actually deliver in time. Because you can easily be stuck in trying to get things started with machine learning and doing many, many mistakes on the way, and you don't even realize if the experience is missing. Then we have the consultants. Not everyone who works with such a data set will actually sit in the same company. Sometimes a consultant will be brought on board with machine learning experience, with Python experience, and for these people, it can just be an accelerator. And then we have like the seasoned data scientist who has plenty of experience and might or might not be interested in doing AutoML overall because these people usually have lots of code stored already, or they think they know everything already and don't have the feeling that they need it. But also for this persona, there's lots of potential in saving keystrokes, saving time, getting inspiration. So we got our data, and the first thing we do, and this is probably for all of the profiles, we actually need to look into our data. Now we jump into a notebook and just see how EDA in BlueCast would look like. So it all starts with some imports. I have more than I need here actually, but the decisive part is here. So basically we have like a bunch of functions that we can use. And EDA, especially when you don't use Tableau or Power BI, can be quite code intense because there are many lines of code, and then you might want to make it more shiny and then you need more code. So what we do here is We use basically a feature type detector that is built basically into BlueCast, just to basically find automatically what are the numerical columns, what are categorical columns, and so on. And then we can start. We start very simple, check, okay, what's the target distribution? Okay, looks fine. Yes? Oh yeah, apologies. Thanks. Better? Or maybe we do it like this? Yeah. Okay. So there's no imbalance, so everything fine from this side. Then we can look at univariate plots. So we just look at the distribution of each of the features. So we get some nice histograms, some box plots. So we can scroll through, see, okay, obviously here we have some ID, so there's nothing useful. Here's a custom ID, but we see already some are duplicated without even looking too deep into the data. Okay, we see some nicer distributions, tenures, probably a discrete feature. So there are many things we can already see from the univariate part, and we basically just needed one line of code. We can also look at the empirical cumulative density functions. Also here it's univariate level, so we get a histogram like as a gray background, and then we can see how like empirically the distribution is evolving. Also from here we can actually get some nice insights into the data. Then we want to see how do our features relate actually to our target. And here we can actually make use of some nice violence plot with the bivariate plots, and we can compare how our features actually distributed with regards to our target feature, to churn. And we might observe some interesting differences, like the number of products. So we see, okay, so a higher number of products seems to have, for some reason, a higher churn probability or likelihood. We see there's a difference in age for some reason. We see also that if someone is an active member, there's also a difference, even though it's a very weird feature in the data set actually. Then we might want to understand, just looking at the categories, how is actually churn distributed among these categories. So we really want to understand how everything behaves here. See, okay, in Germany, we have much more churn than actually in the other countries, for example. Or amongst female, we also have more churn for some reason. We can check the correlation to a target. So we see, oh, age is more correlated, balance is more correlated, and we also have some negative correlations. We can see how our features are interacting with each other on a categorical level, with also some kind of, it's an association matrix technically. And then we can also check if we want to actually exceed the linear relationships, we can also take a look at the mutual information score to also basically grasp nonlinear signal basically. Because sometimes we might see actually lots of correlation, but or even very little correlation, but actually quite some mutual information. And that might tell us, for example, that we should not go for a linear model because the features basically have more than linear signal. Or we can do some dimension reduction, just see if we find some good linear separation in our features. We can check if actually the variance is actually covered with just a small amount of the features, or if we need to keep all of them. So in this example, for example, we see we actually need all of the features to get all of the variance. If we do some feature selection, we will lose signal. We can check which feature would contribute to which of the principal components and how strong. We can see if we have correlation between the features. And we can also do some Andrew curves, which is kind of like a row level transformation. And in this case, actually we see like 1,000 rows, but they're all overlapping. So it's not an easy data set to deal with probably. We also have some leakage detection, basically just as a security check to see if there's some leakage we just didn't think about that pops up, which is good. And then we have some count pairs. So that plot here I kept to see that sometimes you just need to skip over a feature. And then we basically can compare, okay, France, how often does it appear between the train set and between the test set, for example. So we can see also if there is maybe a category that is just not existent anymore in the new data set, for example, and we must need to handle it in some way. So we go once further. Okay, so how might certain personas benefit from the EDA module? So for the stakeholder, I would say it depends on the exact profile, probably a bit limited. I mean, they can see the distributions. They might see that they need to do something about it. Depending on the profile, they might make use out of it or not. So for an analyst, there's probably already more potential. I mean, they can see distributions. If they are experienced doing some linear modeling, they might use it. If they have to build a rule system, they might also basically find some valuable knowledge in these graphs. For data scientists, there is definitely more potential because in these profiles, we can often already draw conclusions from what we see in the graphs to what we need to do on the modeling side. Okay, usually, or often, when we do something in our business at least, and here I'm crossing a bit of bridge between talking private, talking business, we don't necessarily say, okay, we have a data set and we right away start modeling. Sometimes we also just try to start with a simple approach because in the business world, things are more complex. You usually don't have just like a central department and then there's just modeling happening, but usually you have different teams and different teams have more or less resources. Some of them might just have an analyst and not even a data scientist, no engineer. So basically, even if the analyst would come up with the best possible model, he couldn't deploy it. So then the question, okay, how can we even get there? Can we maybe prove the business value of a potential model and then maybe gather the resources afterwards? So one way here could be clustering. Let's go. No, I need to zoom back quickly. And for this, we also have something. I would do this shorter. And for the clustering, so clustering is quite nice because it bridges a bit away between, we can impute our domain knowledge quite well here. So in this case, the only thing we would have to do is actually define how the clustering should be done. So it does it in a flare of an RFM analysis. So we say which features do we want to have. So we want to have number of products, we want to have credit score, we want to have tenure. And then we just say how many clusters this should build internally for each of these features and if higher is better as a feature value. And basically it will, and we just instantiate the feature clustering scorer, pass in these settings, and do a simple fit predict. And then we get basically a total score. And the total score is basically the total number of points that we gathered. We can basically treat this as a cluster on its own afterwards. Now we could analyze as a next step actually how these clusters look like to basically understand if is there a cluster that is very, very different. And here next, for example, we could actually arrive that cluster 9 has a very high churn probability and it's worth investigating that one further. We're almost at the machine learning part, by the way. Okay, so what could we do now? So we have these clusters. Now, in our case, we did some churn treatment. So we actually took this cluster and we targeted it with some CRM campaign or some other campaign and found that we got some good results. So we did some churn offers and we got basically something in return. And now we can actually sell to the business that we really need to go for a fully fledged machine learning solution. So now we come basically to the heart of BlueCast, which is the machine learning part. And we go here. So if we just would like to go, and now I'm just on the GitHub repo here. So let's say we would approach BlueCast the first time. We could go into the documentation, basic usage, and just see This is all what we have to do actually to get a pipeline that predicts on new data. So we just instantiate a class. It's back comparable to the AutoScaler we have seen earlier today. We just do some fit to fit the pipeline, and then we can predict on new data. That would be basically it to just get the full pipeline. I will also show what an end user can actually see while it's running. What is usually good practice though is to start with some baseline. For this, we actually can provide a linear model recipe. So basically, we take this also out of the BlueCast class. It's basically prepared for an end user and just pass it as custom modules. So here you can already see BlueCast is on a high level very simple to use. So like 3 lines of code, we can have our pipeline. But we also have this fairly open API where we can inject our own pre-processing. We can also inject our own model or our own hyperparameter routine if we want. And in this case, we just use that open API for something that is also provided internally and just make use out of it to build here a logistic regression basically. Then we just run the pipeline. In this very example, I did not use a fit method, but a fit eval method. So in the base instance, we can actually provide a holdout data set that the evaluation will happen against. So basically, this one will not be taken during any model training or hyperparameter tuning, but just for the evaluation. I chose to do it like this because I have the feeling that stakeholders usually have a much better intuition of what a good holdout data set is. That might be something that just comes later in time, or maybe something that needs to be done via stratified sampling because we want to take care that a certain category is well represented also in the evaluation data set, for example. That's why this one is provided by the end user. And now what we can see basically is it basically runs here through a pipeline. For this logistic regression, there's also no tuning involved. It's just the baseline. And then we get basically our evaluation, including the confusion matrix, but also some evaluation like log loss, balanced log loss, and so on. You can also see the raw curve. You can see a lift chart to see how much better it would do against a random model. You can also see the probability distribution. So we see there's quite some overlap actually between the two classes, which is not so good. And then we could still retrieve the estimators of our logistic regression to basically then further investigate, okay, what do we want to do? Is there a feature that has lots of importance? If we change the random seed, do the coefficients go crazy? Do we need to change the pre-processing whatsoever? We have many, many options from here. Then we can also just go to the default model actually. And for the default model, what will happen is now everything is the same. It's the same data. It's the same holdout data set. But now we are not passing any linear model, but we are just using what's basically underneath. And underneath is basically XGBoost, but it will be tuned for us. So, and then what we can see is, so we can see what has been the best finance score. That's here. We could technically also change the configuration of BlueCast on the fly to say we want to see which hyperparameter sets it has tuned and tried, like in every single run. In this case, on the default, it will just keep it very tight, so it doesn't consume so much space in the notebook. We can see how the optimization went. So we see, okay, it converged at some point. We can see which hyperparameters have been the most important. In this case, it was class sampling itself. And then we can also see the final hyperparameters. In our business context, what's important for us is often also to understand which features have been most important. So model explainability, model transparency are very, very important. This is why by default, you will also get the Shapley values. So this is basically Shapley values take every possible feature combination set and basically then overall calculate what is the global feature importance. considering that every feature has been in there or not. And in this case, we see, okay, it's number of products and age. And we can also see to which class it contributed as much. And then we also get like evaluation on a holdout data set, ROC curve, lift chart, probability distribution, and so on. We can also basically see the final hyperparameters that we used. And could also, if we have the feeling, for example, that our model overfitted, we could also actually override these hyperparameters after the training and change something in it, and then basically predict again. Unusual practice, seen it once, I think, but possible. So, modeling is only, again, modeling is only one piece of the puzzle. Often improving the model plateaus relatively quickly in terms of overall performance. Then the question is, okay, what do we do? Do we add more models? Do we add stacking? Do we change the framework? But often a good alternative is also just doing more feature engineering. Ideally, if we have more new features at hand, even better. But we might also just work with the features that we have at hand. For this, BlueCast actually has multiple options. So we have seen a clustering before. Technically, it would be possible to use the clustering as a feature itself afterwards. This is not fun. Then we also have the possibility to do row-level aggregations. Can I say, please? And then we can also add group-level features. So also here, we just instantiate a class, and then we basically call a function, define which should be the group by functions, and then it basically does all the calculation. We get the group by data back, and we can conveniently join it back onto our training data set. This is actually quite handy because doing the group by stuff can be quite nasty to do. Also here, internally, BlueCast is actually using polars instead of pandas. I guess everyone has heard about polars. Anyone who has not heard about polars yet? Okay, so, but you know pandas, for example? Okay, so basically, polars is, let's say, like pandas, but you have inbuilt multi-core processing. So it's much, much faster. It's also more efficient usually. And especially when you're dealing with a data set that's like 1 million rows or more, then it will be much, much faster than pandas, especially with group by operations as a significant speed up. But if someone like the analyst profile would start, they would probably ask ChatGPT, and ChatGPT would probably return something with pandas, or they would Google and find something on Stack Overflow. Might also be pandas, because pandas is quite everywhere. So in these cases, it's just quite nice to have some pre-built functionality that takes care of these optimizations already. So then what do we have here? Okay. We might have been not happy with our provided model. And now we are more looking actually at the profile of like the data scientist or the senior data scientist who maybe just needs more custom control. And for such cases, we can also make use of our API in BlueCast. And what I do here is I just define a custom hyperparameter tuning for a catboost classifier. Because I'm thinking, okay, that's categorical data. Catboost is really good with categorical data. So, and basically what we do is we say, we can change the configuration and say, please don't do anything about categories. Let the machine learning algorithm handle it. So it goes all the way until catboost, and catboost can take care of these categories. And so also here, like we had it before, we basically just use the API to provide a custom model, but in this case, it's basically cat boost instead of a logistic regression, for example. So in this case, we just profit from having the custom control. Then I think I had one or two additionally. So, however, so far we have only built a single model, which is totally fine for many use cases actually, because stakeholders like simplicity, and the more complicated it gets, the more complicated it will be to explain. So a single model is usually a good idea, at least to start with, unless you really need to squeeze out more. For these cases, we can actually make use of the BlueCast CV instance. And basically what it does is it will train on by default 5 models and then basically blend them. What we also do here, what I will show in a second, we provide actually a custom loss function, which is also very important because in many instances you might have a problem where you really need to have control over what you are optimizing for. Sometimes you don't care that it's maybe, for example, for churn. You might not care about how many people are churning, but you might care about what monetary value is churning actually. So you might want to focus on, no, it doesn't turn blue anymore. So you might want to focus on like high value churning customers instead of just every customer. And that's why having a custom metric is usually a highly requested feature in such frameworks. Also here, just as a side note, we are just changing also here settings on the fly, which is also quite handy because you can also change how many hyperparameting rounds it does, what's the maximum time you want to spend per model on the tuning. You can even basically disable the tuning at all and just set some parameters yourself. Maybe you have found them somewhere else and you just want to try them. You could also basically just implement them, ignore all the tuning and just let it run through like in a short amount of time. So that one we had. Let's check that one. So, exactly. Okay, we can return. So, we went through now lots of prototyping. We tried multiple models, tried with like a single model, with multiple models, with custom models, with change configurations. And now the question is, which persona benefits from the AutoML module? Stops again. Let's see. So when you think about who might actually benefit from it, there's also some shared experience that I saw when we actually worked with Data Robot in the past. So for a stakeholder, it might actually be nice if they have like a certain minimum level and they can code it themselves, then they can actually also explore like algorithms and see what is working and also learn something new. So when I started, I was an analyst. I had no clue about ML and I saw on Data Robot, ooh, there's XGBoost, and I learned something. They can also get a benchmark, as said before, against their own solution, so they also have some point of comparison. But they can also inject their solution as a custom model into BlueCast and get the evaluation. Because especially, that's at least what I observed, stakeholders often have a hard time getting the evaluation done correctly. It's like they can code something and then they have their train test split, then they might even train, they might have early stopping on the test set and then they evaluate also on the test set. And it's easy to, and then obviously everything looks much better than it would be because the model has essentially seen the test set, but now you evaluate against it and I don't actually see if it was a good model or not. For the analyst, the same. If the ML knowledge is not there yet, it's a good way to actually build a prototype without having all of the traps around evaluating properly. And then for people with machine learning experience, like the consultant or the seasoned data scientist, we have the advantages that they can actually test fast, get nice prototypes done. No, it's red. And also then just basically build on top of that and create custom solutions. Or maybe what's also a possibility is they run basically BlueCast, see what are the best hyperparameters, and then just use them in their custom build pipeline. That's also a possibility, because you might not want to deploy BlueCast, but your own stuff, but you still want to have an efficient way of finding these hyperparameters. Okay, so the models look good, but CM and the sales agents actually want to know why the model is basically predicting what it predicts. So we have seen during the training that we can actually see Shapley values, but we can also see more of our model during the prediction part, actually. So let's go here, I guess. Yeah. So what we can do in such cases, just finding the right spot. Yeah. So usually if we predict, BlueCast would only predict, would only give back basically probabilities or predicted classes. But we can also basically set a small tick box during the prediction, pass a parameter, and basically also return Shapley values during the prediction on the new data. So we can actually see which have been the most important features during prediction. We can also plot this as a waterfall chart on a row level, and I would actually like to show that. So we can actually better understand, because if we are in business reality, we usually do some churn treatment, for example. But before we are applying churn treatment, we want to know for this particular customer, what has been the most important factor that we predicted churn? Was it faulty hardware? Was it just inactivity? Was it unhappiness when they basically contacted customer support, for example? So it can be many, many root causes. It's only blinking red anymore. And come back. So here we see the waterfall chart. So we can see, okay, we have like the baseline value, and then we can see how much which feature contributed to our final prediction, basically. We can also see dependency plots. In that case, they aren't looking so helpful. Actually, it doesn't even show my screen anymore. It's just a static picture. So basically, these things make our stakeholders way more actionable because they have something to work with. So let's say you are a sales agent, you really want to know, okay, what do I need to offer? Why do I need to offer it? If someone had a hardware problem, I don't need to, maybe I want to offer less fees per month, lower subscription. Maybe I want to offer newer hardware. So we talked about the personas. Now we talk about them with a vision on explainability. So who profits from the explainability? So on the stakeholder side, machine learning is not a black box anymore. So we can see, okay, what have been the most important features? Even on a customer or row level, we can see why the model made a certain decision, which makes it more actionable. But also important in real businesses is also trust. Because in the moment a stakeholder can understand how a model works, trust is much higher. Even if it's not the best model, but just understanding it helps a lot. For the analyst, it's kind of the same, but there's also a level of confidence. So if I'm not working with something that's completely black boxy, I have more confidence, because if someone asks me, okay, why did the model decide like this? I can actually show, okay, look at this chart. That helps a lot. You don't fear that questions are coming. And then on the other side, for like the data scientist side, they can basically explain, they can save time, because writing all of these things took me also a year. So there's quite some efforts to cover all of these use cases. And in that case, you can just save lots of time by doing so. Okay, so Kaggle. As mentioned before, Kaggle is a data science competition platform. And I would say in the past years, AutoML frameworks appeared occasionally, but weren't like everywhere. But now in the last 5 months, actually, AutoML frameworks have taken a lot more attention, because there has been a marathon of 5 24-hour competitions. And basically, so for every first of the month, people had 24 hours time to basically make submissions. And it was called AutoML Grand Prix, because Kaggle estimated that AutoML solutions will actually dominate a leaderboard, which also happened. Especially AutoGluon, which we talked about before today, was really strong, also like AutoML. But then when you look at the Kaggle leaderboard, where was BlueCast? So I just brought like three results here. So like in an ICR competition, it was somewhere last year. It finished like top 20%. And then to other competitions was like top 12%, top 13%. At the end of the month, basically. But what does Kaggle not tell you? So depending on what you're used to, top 20, top 12, top 13% might look good or not. I mean, on the other side, on one hand, it means, okay, it wasn't like number one, far away from number one. On the other hand, it also means it was better than 80% of the data scientists who competed and had a full month to actually beat it. But what you see is often, if you look closer, there are small differences. Kaggle leaderboards are very dense usually. There are many copy-paste solutions, so it's also often bloated with someone having a good public notebook. They want to get some upvotes, so they share it, and then people just copy it and basically run the same pipeline themselves. And then there are obviously also multi-architecture ensembles like AutoGluon, who have all the stacking, and then you have CatBoost and XGBoost and Lightroom and neural networks and so on. And then obviously you can beat this benchmark, but I would say performance-wise, it's fine. Given that the library is a year old, I think it's okay. So what did we learn? So I hope I could show what BlueCast is capable of. I couldn't show everything. So we have one algorithm by default. It's easy to start with, but you can go very deep if you want to customize stuff. You can change the configuration, have own pre-processing, own configuration, metrics, models. You can change all of these things, basically. It's almost like Lego, if you like it. It has a good performance, not AutoGluon level, honestly. If you really want to squeeze out the last bit out of something, then at the moment AutoGluon is just the way to go. No one gets around that. But it also has good test coverage. I think documentation is also fine, and it's also maintainable. So it has lots of potential to actually build on top of basically what is there already. We can add more algorithms, we can add wrappers, so we also have more like what people would assume with AutoML, like going through many algorithms and finding what is the best, and even what is the best ensemble, basically. So it also has, that's something I wanted to show, but the screen was black. It also has error analysis. So basically, when you would run your pipeline and you do it with the fit-eval, you can also decide to store the unseen data sets, and then basically use an error analyzer to basically get visualizations of how the errors are distributed for different categories in your data set, for example. So then you might, for example, see, oh, in this case here, we saw the error for non-churners for Germany was way more distributed and varying than for the other countries. So in that case, just for testing, I created a second pipeline that subsampled the other countries a bit, and then predicted for Spain and France with the full data set, and for Germany with the subsampled model, and it actually improved quite significantly the performance. So, but you can do these things if you understand where the model is actually failing. Also, BlueCast has conformal prediction. So, because nowadays, stakeholders don't necessarily only want to know your point estimate. They don't want to know, oh, churn or not, or what is maybe the classification score that your model was returning. That they actually want to know how confident are you that that person will churn, because these models are not calibrated by default. So your score might be 0.90, but actually the probability that that person churned might be 7%. Because during calibration, it appeared that the model was overconfident, and basically, even with a high score, you have a low probability of churn. And then you can basically use inbuilt calibration and return prediction sets. So then you can say, okay, with 19% probability, return and which classes that customer is. And then for some customers, you might get with 90% probability only churn, but you might also receive 90% probability churn or not churn. That makes a big difference, actually. And then you're also more actionable on the stakeholder side, because then you can think about, okay, do I only get in touch maybe with the ones who are just in the churn prediction set, for example? And that's it. So if you have any questions, feel free to approach me or raise them now or make a GitHub issue, contact me on LinkedIn if you want to contribute the same. And thanks for your attention.